My name is Amy, and welcome to Ask the Expert. As you may have already figured, I am a tutor here on Wyzant, and I'm a registered dietitian, and my main area of expertise is in mathematics as pertains to nutrition and dietetics. However, I really enjoy helping just about anybody that really needs help with math. And obviously, I don't mind dabbling in a little bit of physics, but actually, a lot of the skills that you need in solving this series of physics problems is actually lays the foundation for things that you need, and not only to be a mathematician or an engineer, it also applies to a lot of fields, including dietetics. So, without further ado, let's get to this first in a series of problems. And just give me a second here. Before I start tackling that, let's share the screen so we know exactly what we're talking about. That might be helpful, huh? Okay, so get a drink of water, take a deep breath, whatever you got to do, get the screen to load. Okay, there we go. Didn't take too long at all. So, as I said, here's the first problem in a series of problems that somebody posted. And I really want to go through, what I really want to help you do is kind of give you kind of a template, a systematic approach about how to go about solving these types of problems. I like to think of it as, well, sort of like when you have in an English class, you have different types of essays, and you do an outline, and you have certain kind of templates that you have to kind of tackle certain types of English papers or essays, depending on your needs. So that's kind of what I want to do here, is kind of really give you some tips and a systematic approach about how to kind of solve these kind of problems. In addition to the usual logistics of solving them. Okay, so first off, we're going to be dealing with this problem, the first one, and these are actually a series of sequential problems, and they're actually beautifully laid out, and there's no accident. Whoever created these problems, they knew what they were doing, because don't mean to be a mind reader, but I'm pretty sure I know what their objective is, and they wanted you to kind of be able to see something, have an aha moment, and to kind of emphasize some really key points that are very important to understanding physics and math, and not just this problem, but in also in solving future problems. I'll leave it at that. Don't want to give all the hints away before we get going on. So here's the problem. Now, I'm going to read the problem to you and kind of review some tips about how to maybe tackle this problem. It'll start real basic, and then when we get to part 2 and 3, kind of build on some of this. So here's the problem. It basically says a car moves at a constant rate of 5 meters per second. What distance does it reach in 45 seconds? First thing I always say is, what is it that this thing is asking me to do? Okay, simple enough, but I find that sometimes when people have a word problem, or when there's multiple parts to it, they get overwhelmed, and you get to a point where it goes, what was it asking me to do in the first place? Okay, or sometimes there's more to it than just repeating back the question. So here we go. And sometimes it also helps you to kind of draw a picture. That's also another majorly utilized thing in all areas of math. So we have our car, and it says it was at a constant rate of 5 meters per second. What distance does it reach in 45 seconds? So distance in 45 seconds. Okay, so it looks like I need to find a distance, and we need to know how far it went in 45 seconds. Okay, so, okay, now, if it hasn't already, you may have noticed something that is something that you become very good at recognizing right away, and that is we have a rate, we have appears to be a time, and it's something about we need a distance. It's asking for a distance. And what I like to do too with my problems is highlight the keywords. So I've already kind of given it away that this is probably a rate times time equals distance problem. But even if you needed a little bit of more help to help you figure that out, I would go about looking at highlighting kind of some of the keywords here. We have a constant rate. We have 5 meters per second. We have distance. and we have 45 seconds. So our next step is kind of like maybe bulleting those keywords and those key or things that are given to us, and then kind of go and start translating in those words into plain language and really kind of help think about what they mean. Now, this is a very simple problem. When we get to more complex problems, like in part 2, you may want to draw a table. But for now, you can just do it this way. So constant rate, let's think about it. What does constant rate really mean? And again, hint, this is kind of my major point is what I think maybe the objective of the person that wrote these problems, what their objective was, this is sort of kind of part of what they were getting at. Okay, so constant rate. Let's really think about what that means. Translation, a rate, a speed. And what about it? Constant means, you know, never changing, right? So we are talking about a speed that does not change over time, right? Okay, so then we have, like I said, meters per second of meters per second. So that's referring back to a constant rate. So that must be our specific constant rate. Let's write that down. So we're translating that into plain language, and it says a specified constant rate used in the problem. Okay, however you want to word it, it makes sense to you. Distance, okay, that's another key word, right? What does the word distance mean? Okay, it's kind of self-explanatory, you might think, but let's just kind of take a stab at trying to say it in some other words. So basically how far we've traveled, or in this case, looks like it's our unknown variable because we don't have a distance. And like I said, I think I could say this over and over again, rate times time equals distance problems are not going to go away. They're in algebra, they're in physics, and ACT, however, you're going to find it in the math and a word science problem. I know because I've helped people with studying for that. And really, they're just in college, once again, never going away. Physicists just love these, but they also kind of have a foundation for things that you can apply to all fields of study. That being said, okay, can't say that enough. Now, moving on. So what I'm going to do here, just kind of lay it out again. You know, in this case, you know, bingo, ring a bell. Looks like we have a rate times time equals distance. So I'm just going to have to write out what those variables are. I wrote out the equation and kind of put what we translated up here and then put in our variables and what that looks like. So again, the distance is the d. That is what is our unknown is. The rate is our 5 meters per second. Sorry, I didn't have an equal sign there. And our time is 45 seconds. Now, the next thing we need to really kind of will play a role in future problems that we do is we want to make sure that our units are all in this are all the same. Or I'm trying to think of the right word here, but we can't have seconds and minutes if we have to convert our seconds to minutes or minutes to seconds and vice versa. But it looks like we're okay here. So we have meters per second, we have seconds, so that works out just fine. So it means that our distance is probably also, our answer is going to be in meters. So let's go set that up. So we kind of already said that. And we have our rate times time equals distance. So all you have to do is kind of set up the equation and plug and chug, as my math teachers used to say back in the day, plug and chug. It's funny how some of that stuff you just remember. So we have the distance, and then right here is going to be our rate, 5 meters per second, and then we times it by our time, which is in seconds, 45 seconds. So when we do that, one thing you notice is that the seconds cancel out. So now we're left with 5 meters times 45, and voila, our answer is a distance of 225 meters. One more thing that's helpful to kind of think about here is it might not be so easy to so obvious because it's something that maybe is used to calculation of meters to seconds or versus like miles per hour or something like that. But just thinking about whether our answer makes sense. Okay, so constant speed of 5 meters per second. And does that make sense? Well, you did it in 1 second and over 45 seconds, yeah, we would expect to get 5 meters times 45 seconds. So we did per second and then we did 45 seconds. That's so we did the unit for 1 second and then we have to times it by 45 seconds. So at least logically, just making sure that I go through that again and that makes sense. And I believe it does. Again, we cross out the seconds and we're left with 220.5 meters. Again, that's kind of the most simple simple example of how a problem like this is done. In part 2 and 3, we're gonna really, the definitions of what these definitions mean and how to translate are really, really important. And I think that's at the heart of what your teacher wants you to understand. You really gotta understand and stop and think about what that means. And often a graph or a picture will also kind of help you. Really help you understand what these concepts mean, because it can get a little tricky when you get into acceleration and when you get into changes in direction and magnitude, which are vector type things. So we'll leave that for next time. That sums it up. Hope this was helpful, and stay tuned for part 2.